Hi all, my name is Maxim, and I'm going to check with you about different architectures. There are no new things inside this presentation, only architectures, some examples, some images, nothing you can handle. But I want to give you my vision from my perspective of these steps and broad understanding of what are the main questions here. Why it's so hard in some cases, why we use it. Without any doubts, we will use it, and what we can get with, and so on. One more excursion inside architectures, Flutter as the main framework, some slides, and my voice. We have not so much time, so I will be really fast inside like examples, inside slides. Sorry for that. I think you have like pause functionality, so if you have some troubles, please be patient to this. And one more small thing, if you want to promote the senior stuff after this presentation or go to Nirvana, it's not the case. We're trying only to figure out some interesting stuff, some interesting things, and yes, it will be what I will be one more person in your life who can say to you if you want to be like in Nirvana or promote to senior stuff, work harder, dude. So let's start. Who I am, why do I think I can tell you about all of this, and nice to meet you. My name is Maxim. I'm in like several years in IT development. I really worked in different outsources, product companies, different startups, own startups. I understand. I see. I saw many projects. I see now many projects. Check some. Check some. I've worked on like many backend solution, many Android applications before I promote to seniors Node.js developer. I was senior Android developer, so I know something. And let's go to slide. I will like stop video and we can go. Before we start, I need to like present one more person. Khalil Stemler will help me out. Without any doubts, he doesn't know about this, and that's why I hope I pronounce his name correctly. And that's the way how people become famous, I think. And he has a tremendous overview of where the difference between design patterns and architecture, um, when architecture is ended, and it's really important here. In case you don't understand why, please wait till the end. Every part is here for some purpose. Okay, today themes are on your screen. All is really simple. There are some architecture design, map, and architectures. So let's go to architecture design. Stage 1. Here we go with clean code. In case you have done some project tasks, you know there are plenty of ways to finish your task with documentation or not, with testing or not, with appropriated naming or with ABC variables, and so on. It's easy, but you can get further without these things. Or you can pay attention to these details. You can read clean code from Uncle Bob or say it's all about blah, blah, blah. You can check other materials, code styles, and best practices. That's really your choice. If you don't understand why these rules are so important, so I can say only thank you. From my side, much more customers will try to find me after you. Yes, because I know why naming is so important. Pure functions are better, linter and prettier static analyzer. These tools helps me out. I know how to use sound and safety. When do I have to refactor code? Repeatable, fast, independent tests aren't nonsense for me, and so on. But never mind, you can live without it. You write code faster than me, so you're good. And our market is really huge. You can put your place without problems with me. So let's move to like next stage. Second stage, you can see some green lines here. That's part of something bigger picture, but now we avoid these connections. It's not so important for us. So second stage, programming paradigms. You could take a strictly functional or strictly object-oriented approach to write your code, but here is the level when it's good to understand how all of them could improve the quality of your design. You can use uh, object-oriented analysis and functional programming together. Um, so let's move to another stage. Third stage called object-oriented analysis, but it's more about program complexity. And I know there are many holy wars here, but functional programming has less instrument to deal with real-life project complexity. Object-oriented analysis deals with it from the beginning. So when we are speaking about layers, domain entities, connections between them, like composition, aggregation, etc., we use LOP in most cases. But you need to understand it's more we look at this stage, more than simple OP. Stage 4, design principles, not patterns. It's important. We aren't working now with architecture, we aren't working now with screens, but it's good to know how others will provide their solution inside our code base, especially our teammates. Some questions to your teammates: do you use solid, or he prefers grass patterns? Do you prefer kiss or dry? No, I go straight to the goal. And single code line isn't delivered, but some files are punched, and someone may even be beaten. Don't work in such places, but yeah, someone may even be beaten. And your team works with a similar vision and rules by similar after that rules by similar design principles. It's like a good way to deliver project. Okay, stage 5, design patterns. Here we go. Not only gang of 4 patterns, but repository patterns, producer consumer pattern, provider, active object, some cloud serverless pattern, cloud distributed, dependency injection. Really, there are many different patterns. For your clear understanding, the pattern is the best general solution to a design problem that recurs repeatedly in many different projects with such circumstances. If you have other circumstances, so you know what to do, change your pattern. If you need to know how to write your solution in that way, all will be good in future. Really, dude, it's not design problem at all. So if we are talking in a serious way, architecture patterns are just design pattern in scale to the high level, where design patterns are low-level implementation closer to classes and functions. It's really different levels. Also, design pattern can create an additional complexity to your app, but it can help other teammates understand what you solve here and how. Because you use this design pattern, all patterns have their own problems they solved. This is simple, I think. So, stage 6, architecture principles consist of component design principles, how to organize components, their dependencies, when to couple them, couple them. You know how to write, and the implication of accidentally creating dependency cycles and rely on unstable components. And you can check here the stable abstraction principle, the stable dependency, some boundaries, and how to identify the subdomains, that the features of all applications belong within abstractions versus implementation. And for understanding how to separate the rules of your application from the implementation details, like on stage 4, it's only rules with no code and decisions, only how we can deal with our code base, but on higher level. Okay, next stage. Here is our stop, and we figure out all the customers' requirements. We have to meet them. For example, a system that has a lot of business logic complexity would benefit from using a layered architecture to encapsulate that complexity. A system like Uber, from other side, needs to be able to handle a lot of real-time events at once and update drivers' locations, so the publisher subscriber style might be most effective. Here we go with such questions: how we will deliver our product, what components do we have in our system, and what connections coupling between them, are they independent? Do we have here events, cron jobs, third-party service, background services, and so on. Configuration, crashlytics, internationalization, logging, etc. We have different requirements for our business, and part of them can create more and more questions we need to solve at architecture level. And so our architecture will be like a template for our application. After you choose the template, you will use like you have many more questions you need to deal with. All previous stages will help to reduce the price of such choices if you will take into account all the details, and will choose the right solution. Your architecture will help you to deliver really bug-free application with all new features your customer want. All of us want to cooperate with happy customers, don't you? So here is segmentation. You have your architecture and you have some other solutions to deal with project complexity. And today we will speak about such templates. Before that, to summarizing all the stages we are speaking about, please check it one more time to understand, because in my templates I will try to show you simply how to deal with it inside architectures, inside our templates. So first one, the simplest one, our first one architecture is MVC. There are some layers like model, simply data source. It may be from anywhere, database, APIs, third-party services, etc. Like Firebase, I don't know. What do you prefer? View. It's all about the user interface displaying data and taking inputs from the user. Controller layer. It contains the app logic controlling what data will be shown to the user. User input handling. All business logic is here. This pattern goes from 60s or 70s or like from last century. So here user uses controller. It goes from times when user communicates with simple console. In that programs, user can work with a controller in that but it's not so important for us now. Please be patient. Now your client is working with UI. UI is called by controller, and you understand the background service also uses controller. Some links can go to the controller, and really controller checks we need to open some UI, the control. And in good application, your model knows nothing about your application. If it could be used in another application, so you have really good model layer. That's how it works. Working in a simple way. That's the data you choose structures. Everything else is going to control. Everything else is going to controller. Sorry. Good question. On which layer do you validate your input data? Will you have some business logic on the model layer? Will you use ORM? Which pattern do you use for model repository, active record, data mapper, or another one? How will you connect to third-party services? Will you create some delegates for that? Now you understand why I waste so much time explaining at which stage we are. Here are all the questions about code style, entities, hierarchy in your project, patterns, etc. Here are all of them. One more thing, that's the simplest architecture. If you can't be consistent in this architecture, so you are in big trouble, I think. Freelancers, it's not so important for you. Don't do this. Your customers, with your help, will understand why we outsourcers are so expensive. I mean, expensive. You understand. And I'm joking or not, like it's your choice. I want to sum it up. Such separation is important for the maintainability of your Flutter project. Let's go with simplest example, really the simplest one. So let's go with model. Really the simplest one model you've ever seen. We have like counter and we have actions to change this counter in our memory. Correct. Controller. The simplest one controller. We get like counter inside, we move counter inside controller state from the model, and we have like different actions. Now it's similar to model because we have a really simple application, but you must understand, you have to understand that you can change it in every way you want. View. Simply, we have like small widgets, small like page and widgets in which we have like our controller. Here we go with this controller without any injections, without any stuff. Simply use, we can use like set state, inner functionality from the Flutter, and increment counter actions from controller. Nothing interesting, nothing heavy. Let's go to MVP. Here we are. There are some layers: presenter, view, and model. So the model is interface defining the data to be displayed, or otherwise act upon in the user interface. The view is a passive interface that displays data, the model, and routes user commands events to the presenter to act upon the data. Set data. The presenter acts upon the model and the view. It retrieves data from repositories or some other patterns. It's not so important. The repositories, the model, and formats it for display in the view. So in the MVP pattern, the presenter is the middle mediator handling the model and updating the view. In the MVP, view and presenter are completely decoupled and communicate with each other by the interface. It's important because of the decoupling, such decoupling that it's really easy to mock data for unit testing. You don't need UI testing or like integrational testing. You can live with only unit testing. You haven't any functionality on UI, so it's like easy for you. All questions are the same from MVC. You remember what is your model, how do you implement your configurations, login environments, Crashlytics, and so on. Let's go to MVP. Hurry up, we have like really interesting examples later. So MVP model, you see in memory, nothing interesting, more stuff, but only to deal with more data. To show you how it can be. Also, let's go with presenter. You see like iPresenter class interface. Sorry, here we are like with simplest methods. So we implement such iPresenter. We have like methods we get from this interface, and you can check. We have like our business logic, get some data or save some data in this way in model, and send some information to our view. uh, all is simple. I think you understand what's going on. We have view. About view, some simple and interesting stuff. We have interface also. Simply, so in presenter you use iView. It's really easy to mock this. So you send all your data to view. Here on view, you implement iView. One more time, the simplest example ever to show you how to deal with it. So you have like set state, you have like different methods, you have like sending data within view and from view, in and out, and you can check all the stuff in view is pretty straightforward. Nothing interesting, nothing so important for us, and we can move further. MVP interfaces, all is simple. Block. Here we go with like one of the main favorite architecture from the Flutter. And Flutter block is simple to use. You have UI states, you have the simplest event ever, all layers are known before. This library has very good documentation with tons of examples, and also is one of the most used in the Flutter community. So if you have any questions or problems, you probably are going to find the solution. Many projects are using this library inside from the for the state management. Another important aspect of this library is that you could test your block logic in an easy way also. More details, anything can be an event producer. Almost anything, this event comes to needed block. The block goes to request data and returns a response to uh, get a response to inside, and view is going to be listening to all possible states that the block could emit to react to them. So simply, simple example without any like strange actions. Firstly, I think you know this code. It's like uh, when you create new application in Flutter, you will get this code. It's like the simplest counter ever. So you have like stateful object state. Inside it, you have like counter, and you can like push some button to increment it. In block, we have absolutely the same. You have like state +1, -1. It's like emitting our state to send it to UI. We have different events. As you see, you have like abstract class counter event here. And as your state, now we use integer. But you understand, I will show you further that you can use also one more hierarchy for states. So counter events, nothing interesting here. page also is really simple. Here is our like count. So we use block builder to get this data, to catch this data changes. Also, in that way, you can go with block. You have block, you have like new events, and you send this event to this block. Nothing interesting, nothing special. Another way to use, I only show you this possibility is here. I need to hurry. Only to show you that there are some block observers, you can use it. And big drawback for me in blogs that, for God's sakes, how many events you can have here, and states, and all these hierarchies on different screens. If you have big application, you can move to some state class, but it's like is going to be some trash class, and after some time you will have one more many more trash classes in your project for all states. In It's if you have one big web page with different block providers on the screen, you really will have too much events from my perspective. So please check, maybe it's okay for you. So it will be good because as I said before, this library has good documentation, and it's one of the most used in Flutter community. So stacked architecture. Stacked is a modern Flutter state management with top-notch separation of concerns and dependency injection. Separation of concerns involves separating all UI code from logic. Who expected it? But stacked was found by Dane, Google developer expert, and he combined their advantages in building stacked. So there are some separations in these three different entities: view models, and services. Who know a VVM? We will talk about this later, but that's like a huge start for MVVM. And one more time, with dependency injection, you provide a class with the services dependencies it needs for proper functioning. In turn, this services abstract out and handle the app's business logic. Stacked implements separation of concerns. View handle only UI code and are linked to view models. View model accompany views and handle UI logic. View models use services. Views should never access services. Note that stacked use change notifier Flutter common functionality. So let's go with stacked. Here we go like with view model, like common like middle class inside this architecture. Simple to do application, here we go with like to-dos. Now we get it from to-do service. As I said, better to get all the data from like model. But view model can use such services, it's okay. So let's go to to-do service. Yeah, one more time, the dependency injection, with which with get it, you can like get all classes you want. To-do services, really pretty simple. There are to-dos you need. There are some like methods to get with to work with these to-dos. Some saving. Here we go with Hive, common NoSQL library from Flutter, and you can go with like say to Hive. Here I comment that commented that, but you can uncomment and work with it. Also, notify listeners, as I say, change notifier is working here, so all is okay, all is simple. Um, one more time, here we go, like get it instance, our locator, dependency injection, how we deal with it inside like Flutter application. And here we go with view to view. Simply, it's like our view model. Sorry for misconcept, but we have to do map it to list tile widget, get all the data, get some actions, and all is pretty simple for real. One thing I want to check here about entity folder. Please don't hesitate to create it. You have your domain, you have entities from this domain. It's so much easier to read such app when all entities are in this like folder are here, and you check it and see, okay, I know domain, so what's going on here in business logic. That's my main task, and I can deal with it without any problems because I know on what basis there are. In case you find another entity, okay, it's not from this application, it's from some other library, I can deal with it. It's really valuable, or it's really valuable if other developers can deal with your code. Okay, we go to next architecture, MVVM, like huge start from stacked to MVVM. View model occupies the central position, which sends and receives the data from the model and provides the data to the view. It also observes the data changes that occurred at the view and responds accordingly using the model to the view. To write an adaptable code base, app developers need to build a view model layer that can be utilized by several views. The main point is here in that you change one value inside the app state and all application is rebuilt with this new value. It's really the simplest way to deal with controller state. You have values, view knows how to react to changes, and you simply implement only business logic changing needed variables. But that's how it works in a real world. Let's dig deeper into how it works here in our world. Pretty straightforward, simple, sample. Let's go from async model, our entity, all is simple. Um, so we can save some movie. You have place for sending it to Firebase or to API to database. You know all the stuff. So that's our model. I think view model will be better to show you that. Here we go one more time, change notifier. Here we go with movies. Here we go with only one functionality to show you how it works. Fetch movies. Which goes to some web service. It's not so good. Better to go to model in which we will call web service. But for real, I want to show you that view model can handle with different managers or different other functionalities to get all the data inside and like get some provide some business logics. So in my case now, web service, and one important notice, that's only for samples. Please don't use it in real applications. Be patient to that. Check more like more clean samples. In that way, I want to only to show you, I have not so much time. I want to show you all the stuff. So web service, here we send all the data in movie models. In here, we like get all these movies and send it, like link on movies inside view, and after changing, after movies will be changed in future, would be changed, view can update herself without any problems. Here we are, like our view model. Um, One way of that is use like this provider in the to fetch these movies, or simply fetch movies from after submission. In movie list, we can go with these movies and like get list view widget builder and send all the data here. Simply after changing movies, sorry, one more time. If you change this variable, so all the changes goes to view. That's the main point for MVVM. You have like use here some streams or something, some another libraries to get it done, because here you see I use like simple Flutter functionality, inner functionality. Uh, I will show you in next like examples how to deal with it. So clean architecture. This I think you saw this image. You have seen this image for many times. So before I started to speak about clean architecture, I want to deal with previous stages and previous. So some rules to explain what's going on. Do one thing. It's a good principle. Function should do just one thing and do it well. Single responsibility. A given method class component should have a single reason to change. Dependency injection. As much as possible, class dependency should be provided by objects outside of the class. One more time, that's how all is working. You have to learn all previous stages to have the possibility to create really working architecture. Because the only way to go fast is to go well. Robert Martin. Okay, so about clean architecture. Before, one more definition, use case. The software contains application-specific business rules. It encapsulates and implements all of this use case of the system, and these use cases orchestrate the flow of data to and from entities and direct those entities to use their enterprise-wide business rules to achieve the goals. So presentation layer is the most framework dependent layer, as it contains the UI and the event handlers of the UI. Also, there is the code for state management, such as providers, block, and so on. You're like here, and you can combine the main layer is the innermost part of the layers, no dependency with other layers, you understand, and it contains entities use cases. The domain should only be concerned with the business logic of the application, not with the implementation details. This also allows for easy migration between platforms should any issues arise. Data layer represents the data layer of the data storages of the application. Sorry, the data model, which is a part of outermost layer, is responsible for data retrieval. Let's go with samples. Okay, we have like entity, weather, and here we go with interesting stuff. We have like entity weather and one more class weather model, which are representation from for like entity inside our storages inside our model class, inside like our domain layer. So please, you can use this stuff. You can use it like something like in that way to deal with complexity. To show you need two different interfaces for this class. Please don't hesitate to use such solution. Simply, we have like our use case, get current weather, only one use case, simple as hell. Repository get current weather from repository, and here we go with another interesting thing. Here we go with functional paradigm. You see like either you can check also right left. It's all about functional paradigm. It's all about functional implementation. You can use Dart-Z library from the inside the Flutter to get all this functionality in your project, and remote data source in our like repository. You see we have like interfaces like abstract classes for our weather repository, for our like data source. In this way, you have like one more layer on that. So you can use it for check what other remote data source can be used here, or maybe for injections, or maybe for other stuff. Be patient to that. And remote data source get current weather. All is simple. We get from API some information. This result we will send, or we will send error inside our use case. And our use case is pretty simple. We have like failure in if there are some different problems. We have like data if all is okay. So we go to block, how we can combine all architecture, not all but some of them, because whether block is using really in many places, in many projects. So I want to show you another way to how to deal with block. Sorry. So there is our use case, sorry. And after we get this data here, before we like emit our state weather loading. After we emit, we can like in failure state, we can weather error or weather has data and send this state to our application. Weather event, you can see on city changed, only one weather event, only one event in our block class, and weather state, many different states, because we need to like control what our application can do if there are some failure. So our block use cases are provided, and on city changed, we can like send our event if we want to get another data. Block builder for our state, for a block builder for our like usages for our view, different states, different functionality on these states, different view for our customer. Weather error, we have like center, in another way if state is on the default size box. All is pretty simple, pretty straightforward, and I think we can deal with next architecture. Hexagonal, it's like last of them. So main feature of the hexagonal architecture is opposite to common layered architecture style, is that the dependencies between our components point inward towards our domain objects. Every communication to and from the outside happens through dedicated ports, input ports, as simply use cases. So domain objects can contain both state and behavior, because domain objects have no dependencies on other layers of the application change. So changes from other layers don't affect them. They can evolve free of dependencies. Use cases, we know like abstract descriptions of what users are doing with our software. So code contains all the business rules, validation, and logic that are specific to that use case. And those cannot be implemented within the domain objects. Everything else is delegated to the domain objects. Input and output parts, pretty simple. Domain objects and use cases are within the hexagon, within the core of your application. Every communication to and from outside happens through dedicated ports. Input ports are a simple interface that can be called by outward components, and that is implemented by use cases. And the component calling such an input port is called an input adapter or driving adapter. Output port is again a simple interface that can be called by our use case if they need something from outside. Database access, for instance. And here are the closest sample to like enterprise usage. Here we go, like our entity, pretty simple entity to work with for this, like for this sample. Also, here we have our model. You see like injection inside. You see like different use cases here, different ports to deal with to get their like entities to the, and here we go like abstract classes to explain, to define what's inside our use cases. Login command is a good way to handle like states, to handle different information inside such use cases. And here we go with different parts to get some outer functionality. Okay, let's go to our adapter. Similar to the domain objects, one more thing, use case class has no dependencies and outward components. When it needs something from outside, we create an output port. Output ports, as you see, designed to fit the needs of the use cases, but it's implemented by an outside component called an output or driving adapter. If you're familiar with the solid principle, this is an application of the dependency inversion, D in solid, because we are inverting the dependency from the use cases to the output adapter using an interface. With input and output ports in place, we have very distinct places where data enters and leaves our system, make it easy to reason about the architecture. Output adapters like this one, you see with these parts and with this functionality. I have no Firebase in this project, but it's not so important. You can uncomment that and like use it. Most important things that you have like messages from your parts and you have implementation from the adapter. So output adapter or driving adapters are called by our use cases and might, for instance, provide data from a database. On an output adapter or Firebase, as you see, note that the interface are dictated by the use cases, not the other way around. Adapters make it easy to exchange a certain layer of the application, and the application should be usable from a fat client. Additionally to the web, we add a fat client input adapter, and so on. I think this I want to show you more about our service, about use cases. As you see, there is like connection between services, use cases, ports, and our adapters. So let's go one more time. Another block. We have like use cases inside this block. We have different handlers for our events. There are like hierarchy for our event, for our states, nothing interesting. You can see you emit like such states and set all the data. In UI, it can go in one more time, log out. Yeah, you can in that sample you can see like states goes to navigation and like controls our navigation, and here we go with like UI. Here we go with some event which we send to blog. Um, After that block is okay, we can go to our use case. In our use case, we can go to our like service. In our service, we can go to our like port. In our port, we can go to our adapter. Here we go. Here we have some functionality. Uh, I'm trying to show you if you have many layers, so you have only one problem in your application, many layers. Please be patient. If you have small application, maybe you don't need so much stuff. If you don't need block adapter, so please use internal Flutter functionality. If you don't need dependency inversion, so feel free to avoid it. And that's my last word for this like webinar. Um, I hope it was funny for you, and you know something, some interesting details, stuff, architectures, and you will use it in your future project. That's all from my side. Thank you and goodbye.